Hello, welcome again. Today we're going to talk about geometry section 444546, kind of a combination of all of the sections there from our text, but the biggest thing is talking about using congruent triangles and then proving things with that. Okay, so again, a combination of all those topics. The title CPCTC kind of explains it all. Congruent parts of congruent triangles are congruent. Notice the red parts, or the red letters, are the abbreviation CPCTC. When you prove triangles congruent using either SSS, SAS, AAS, or ASA, the parts of each of those congruent triangles are also congruent. So if you have two triangles that are congruent proven by those pieces, we know then that all the other parts of those triangles are also congruent. Given this example, triangles ADB and CDB are congruent by side, with DB being congruent to itself by the reflexive property. So we know that the triangles are congruent by side. After the triangles are proven congruent, we then can say that the angles are also congruent. So if we know the triangles are congruent, we can make the statement that angle A and angle C are congruent. And the reason for that, and we'll use it in our proofs, is by the CPCTC. So what we're going to do here is we're going to take our proofs to the next step. Up until this point, we've proved different parts of theorems, different statements, postulates, etc. And just recently we've also added on proving triangles congruent. Now we're going to prove triangles congruent and then use the information from those triangles being congruent to prove other things congruent as well. Let's start with our first example. Given AB is parallel to CD and BC is parallel to AD, we want to prove that AB is congruent to CD. So just thinking back to what I said a second ago, we're going to try to prove, if I can somehow prove that triangles, if I look at the picture here, triangle ABD and triangle CDB are congruent, then we know all the parts are congruent of those two triangles, which therefore AB and CD are parts of that, which means they're congruent. Alright, how are we going to do this? Starting off with our given. I know that I have this line BC parallel to AD, and I know that I have AB parallel to CD. We've done problems similar to this with lines being congruent and parallel. Now I have just parallel. Again, remember parallel lines talk about Z's, right, or having alternate interior angles. So if I have AB and DC parallel and I have my green line in there for the transversal, I know that angle ABD and angle CDB are congruent by the alternate interior angles theorem. Similarly, I have a second Z, okay, with the black, and I know that the angles ADB and angle CBD are congruent, again by alternate interior angles. I want to prove those two triangles congruent because it'll help me out. I know that BD is congruent to itself by the reflexive property. And if BD is congruent to itself by the reflexive property, then the two triangles, ABD, triangle left in red, and triangle CDB, triangle right in red, that those are both congruent triangles by angle side angle. And if the two triangles are congruent, then their parts are congruent. So therefore then AB is congruent to CD by the CPCTC. So let's write that up. We stated angle ABD is congruent to angle CDB. That was the first one done by alternate interior angles theorem. We also can note then that angle ADB and angle CBD are congruent by the alternate interior angles theorem. We have, of course, BD being congruent to itself by the reflexive property. Now that we have the angle side the angle, we know that the triangles, triangle ADB is congruent to triangle CBD by angle side angle. And lastly, once the triangles are congruent, then the sides or the parts of those triangles are congruent. So AB is congruent to CD by the CPC-TC. Again, we no longer are satisfied with just proving in step 5 that triangles are congruent. We want to prove triangles congruent and then show out their parts are also congruent. Alright, next one. States C is the midpoint of AD and C is the midpoint of BE. That's the given. Prove that AB is parallel to DE. So think back to chapter 3, and we proved parallel lines to be congruent. And if you remember or recall from that point in time, the only way that we could prove that parallel lines were congruent was by using one of the angle converses, such as corresponding angle converse, alternate exterior angle converse, alternate interior angle converse, etc. Okay, so I need to work backwards now to show that AB is parallel to DE. Well, let's start with some things that we know. I know that C is the midpoint of AD, so therefore AC is congruent to CD. C is also the midpoint of BE, so therefore BC is congruent to CE. You're going to tell me that I have a bow tie, so therefore I have vertical angles. So therefore angle ACB and DCE are congruent by the vertical angles theorem. And then I know that two triangles are congruent by side angle side. So let's write some of that up. Okay, AC is congruent to CD, BC is congruent to CE by the definition of midpoint. Okay, I don't know necessarily yet, or maybe I do, how to show that the two angles, that the two lines are parallel, but I can definitely prove the triangles congruent, and that will be a start. Angle ACB is congruent to angle DCE, we said by vertical angles, which leaves me with the two triangles, triangle ACB and congruent to triangle DCE by side angle side. Excuse me. Now that I know that the triangles are congruent, let's take a look and step back a little bit. I want to show that line AB and line DE are parallel. I have two transversals, and we talked about this problem on the previous step or something like it. If I have a transversal BE, okay, or a transversal, for instance, make it blue, AD, okay, that's the Z idea coming through. And whether I'm talking about the blues or the greens, if I show that, for instance, angle A and angle D are congruent, or if I show that angle B and angle E are congruent, then by the reverse of the Z, when the Z is the alternate interior angles, I will have that the parallel lines that the lines are parallel. So let's make the statement here, at least that one of them are congruent. So we're going to go stick with the blue, that angle A and angle D are congruent. So we have my blue line, angle A and angle D, they're congruent to each other. If I look at just the Z part with the blue, the angles A and D are congruent because of the triangles being congruent, so therefore by the CPC-TC, which we just talked about. Those two angles are congruent because they're congruent parts. If those two angles are congruent, then I can state that the two lines are parallel because those two angles are alternate interior angles, and by the alternate interior angles converse, then, since they're congruent, the two lines are parallel. Alright, next problem. Given that angle 1 is congruent to angle 2 and angle 3 is congruent to angle 4, prove that triangle ABE is congruent to triangle ABC. Alright, let's write in what we're given. We're given that angle 1 and angle 2 are congruent and that angle 4 and angle 3 are congruent. We're trying to prove that triangles ABE and triangle ABC are congruent. So let's just highlight those for a second. ABE and ABC. Alright, we're trying to prove that those two blue triangles are congruent. I noticed right away that the two blue triangles share a side, so we can make the statement that AB is congruent to itself. And angle 1 and angle 2 are congruent, so therefore I do know that I have a side and I have an angle congruent. So if I can get either another angle or another side congruent, I will be set up to prove that those two triangles are congruent. Looking at those parts, if I could say somehow that side AE is congruent to side AC, then I could show that the two triangles are congruent by side angle side. So if I can somehow show that those two are congruent to each other, I'm going to be in business. Alright, let's take a step back here. It's given to me for a reason that I have those two sets of angles being congruent. 3 and 4 need to be used somehow. Let's take a look at that kite and kind of like step back a little bit from it. What if I take a look at these two triangles? Triangles ADE and triangle ACD. If I look at those two large green triangles, well, I notice that I have two of my three angles congruent in those two large triangles. If I could show that those two triangles were congruent, I do know that I have AE and AC as parts of the triangle. So if I could show the two green triangles being congruent, then I know that the parts of the triangles are congruent. So therefore AE and AC would be congruent, which is what I wanted from the previous step. So let's see if I can prove that. I notice that I have a similar side. I have AD, so therefore I could say that AD is congruent to stuff by the reflexive property, and then the triangles, the two big green ones, by angle side angle would be congruent, which then gives me that the two parts are congruent. Alright, so I have my setup. Let's write some of this up. I have my given, of course. Things that I can state right away. I know that AD, the big long piece, is congruent to stuff by the reflexive property. If I know that I have the reflexive property, which is the side being congruent, and those two angles, I know the triangles are congruent. The triangle AED and triangle ACD, those are the two big green triangles. And that, of course, is by angle side angle, because the angles were given to us right away in the reflexive property then. The two big green triangles leaves me with side AE and AC, so therefore those are congruent by the CPCTC. I have that middle part I was talking about before, AB, being congruent to itself by the reflexive property. And now if I take a look at my pieces, I have angle 1 and angle 2 and two other sides, which is great because then the two triangles are congruent by side angle side. So here we were trying to prove a triangle set congruent to each other, but we had to use another triangle set to prove a piece of that triangle congruent to get to our last step there. Again, it's utilizing in these multi-step problems different situations that we've handled in the past. Alright, next one. Given BD bisects angle ABC and AB is congruent to BC, prove that CD is congruent to AD. So what does it mean to be bisecting? Well, or how are we going to get to this point? Well, let's say the given first of all, and then use what the given says to us. BD bisects ABC. ABC, so BD bisects it. That means that angle ABD and angle CBD are congruent to each other. It tells me that from the given that AB and BC are congruent, and I want to show that CD and AD are congruent as well. Also the outside two pieces. I want to show that CD and AD are congruent. If I could show that those two triangles are congruent, then AD and DC would be congruent because they're congruent parts. They're on those triangles. So let's try to prove those two triangles congruent. Well, I notice that it shares a side, so therefore I have the reflexive property. And if I take a look at my pieces, I have side, angle, and side for my two triangles being congruent. So I'm set. Let's write it up. Angle ABD is congruent to CBD by the definition of an angle bisector. BD is congruent to itself, BD, by the reflexive property, which leaves me with the two triangles ABD and triangle CBD by side angle side. And I'm trying to show that CD and AD are congruent, and they are, by the CPCTC. Alright, next proof. HJ is parallel to LK and JK is parallel to HL. So I have HJ parallel to LK and HL parallel to JK. Have a similar setup. I'm looking to prove the two angles congruent. I'm trying to prove LHJ. LHJ, that'd be this angle here. I'm trying to show that one, and JKL, that's this one right here. I'm trying to show that those two angles are congruent. If I can prove that the two triangles are congruent, then I will have those two angles being congruent as well. Well, parallel lines, it's going to lead me to lines in transversal. I know that I have this Z here, the blue one, which leads me to talk about Z. I have alternate interior angles. I have alternate interior angles there. If I take a red Z, I have alternate interior angles here and here. I have the reflexive property LJ. I have angle side angle then for the two triangles, and then I have those by the CP/CTC. Okay, see how some of these are gonna kind of get in routine here. Same steps over, same figures. We have our given, of course, and then we need to start writing up all the angles. So I have angle HLJ is congruent to KJL by the alternate interior angles theorem. We have angle HJL and angle KLJ proven together congruent by the alternate interior angles theorem. We have LJ congruent to LJ by the reflexive property. Two triangles then congruent, triangle LHJ and triangle JKL by the angle side angle postulate. And with the two triangles being congruent, we know that LHJ is congruent to angle JKL by the CP/CTC. Alright, next proof. MS is parallel to TR. MS is congruent to TR. So I have MS congruent to TR and also parallel. It says show that A is the midpoint of MT. Well, what does it mean to be the midpoint? To be the midpoint, it means to divide up equally a line. So therefore, I need to show that MA and AT are congruent, because that would mean that A is in the center. So I have to show that those two are congruent. To show that those two are congruent, I probably would need to prove that the triangles are congruent. And if I notice, I have a bow tie and also parallel lines, so I'm going to have some angles being congruent. Alright, let's see what we can put together here. I have my given, of course, and I want to mark up there. I know that angle M and angle T are congruent, angle S and angle R are congruent by the alternate interior angles theorem. Right, we have our Z's in here, right? We have the green Z, we have the red Z, okay? We also could go a vertical angle route with the bow tie, but we don't have to here. So we have angle S and angle R congruent, we have angle M and angle T being congruent, alternate interior angles theorem because of the parallel lines. So that helps us out a lot because we have the two angles on each triangle and an included side. So our triangles are congruent. Triangle SAM and triangle RAT are congruent by angle side angle. With the triangles being congruent, then all their parts are congruent, which means that side MA and side AT are congruent by the CP/CTC. And if side MA and side AT are congruent, that means that A is in the middle, which means A is the midpoint by the definition of a midpoint. That's what it means to be a midpoint. Alright, last example here. Given QT is perpendicular bisector of US, also that QV is congruent to QR, and VQU angle is congruent to angle RQS, prove that QUV triangle is congruent to triangle QSR. So we have a lot of pieces. Let's mark up one at a time. QV is congruent to QR. And VQU here is congruent to RQS. RQS there. And we also have something about a perpendicular bisector, which we'll get to. I'm going to try to show that QUV, so this triangle over here, QUV, I want to show that the blue triangle is congruent to triangle QSR. So I want to show that two blue triangles congruent to each other. I have a side and I have an angle. If I can somehow show, for instance here, that either angle V or side QU and side QS, if I can show that those are congruent to each other, then I would have side angle side. Alright, what's the new piece of information that I haven't used yet? Perpendicular bisector of US. Perpendicular bisector means two things. It means that I have perpendicular lines which create right angles. It also means that I have kind of a midpoint, so therefore UT and TS are congruent. So you're saying to yourself, hey, this kind of looks like a triangle in the middle. I share a side here, these two inside triangles. By the reflexive property, I have side angle side, which then would lead me to the CP/CTC for those other two parts. And I'd say, yes, you're right. So let's write that up a little bit here. Gotta start with the given. Then what do I know? I know that UT is congruent to TS. Why? Because by definition of perpendicular bisector. That's what it means. A bisector cuts that segment into two equal parts. Further, I know that QTU and QTS are congruent by definition of right angles. I have my perpendicular bisector that forces those to be right angles, therefore they're congruent to each other. I know that QT is congruent to itself by the reflexive property, which then leads me to these nice green triangles being congruent. Right? Those two green triangles are congruent by side angle side. If those two green triangles are congruent, that means that all their parts are congruent to each other as well. So therefore QU and QS are congruent to each other. And if I have QU and QS congruent to each other, then I have side angle side for my blue triangles that I started off with, which is what I'm trying to prove. Oh, I'm sorry, the QU and the QS is congruent to each other by the CP/CTC. And then lastly, my two triangles are congruent to each other because of the side angle side congruence postulate. So again, this is another one where we had to use definitions in different parts just to prove that the two triangles were congruent. So we've had a range here. We've proven lines parallel. We've proven angles congruent. We've proven second triangles congruent. We've proven midpoints to be true. So there's a lot of extra steps and a lot of extra parts using congruent parts of congruent triangles being congruent. The CPCTC. Excuse me, I think I said that wrong. The CPCTC. Problems that we're going to be working on from this section are from page 269, number 26, as well as page 278, numbers 12, 17, 18, 19, and 20.